Hi, I'm John Sloat. I'm a hydrologist with SonTek Incorporated, and I'm here today to talk to you about our new irrigation flow meter, the SonTek-IQ. I'm in the Northwest Province in Southern Africa, and behind me is the largest natural spring in the Southern Hemisphere. I'm actually standing at a diversion point where they divert the water from the spring to the irrigation district downstream. A little bit downstream from this point, we've installed a SonTek-IQ, and I'm going to go explain to you the operation, the installation, and how we use it to monitor the flow. Okay, what I have here is the SonTek-IQ Power and Communications Interface module. Using this module, I connect the IQ using this cable to this module. I apply power. You can see I have a small 12-volt power supply there. And this is where I have my communications. I have a variety of communication options, first being SDI-12, 4-to-20, Modbus, and of course RS-232. Okay, now I'm going to talk to you about the technology that we use to measure discharge using the SonTek-IQ. Okay, here I have the SonTek-IQ. There's actually two models. The SonTek-IQ standard has an operating range of 8 centimeters or 3 inches up to 1.5 meters or about 5 feet. For the IQ Plus, it has the same lower end range, that is about 8 centimeters or 3 inches. But it has an extended maximum range up to 5 meters, or about 16 feet. So let me talk a little bit about what's inside this instrument. Okay, as you can see, it's a very low profile. We've designed it this way to provide a minimum drag in the bottom of the canal that allows you to mount it, of course, much lower to the channel bottom, and also it disturbs less flow, so it allows you to measure accurately in much more shallower water than previous. We actually use acoustics to measure velocity and water level. Okay, the transducer, these are acoustic transducers. They have a 3 megahertz frequency, and these outside beams here are what we use to scan the velocities in the channel. Okay, the next measurement that we need is actually the water level, and so we make the water level measurement using this 3 megahertz acoustic vertical beam, and we also have a pressure sensor that's embedded inside the housing as a redundant measurement. As with any type of acoustic measurement, we also need to measure the temperature for every measurement, and you can see the little brass fitting there. That's the temperature sensor right there. Inside the housing, it's completely self-contained. Okay, the electronics to actually make the measurement, to store the data is all inside. There's a 4 gigabyte recorder, which gives you storage space, for example, of about a year. Say if you were sampling data for 2 minutes for about every 15 minutes. Okay, you can see this is the connector right here. It's a watertight connector. It provides the power and the communications to the instrument. All of the flow algorithms and all the technology again is inside this unit. It's very, of course, very lightweight. You can see that we have little mounts on the side here. Okay, I'm going to go through what's in the box here in a minute. And what this is, these is where we put a little mounting bracket that we can mount it to the bottom of the stream. Okay, we've finished our data collection for today. We've pulled the actual instrument out. We put it all back in the box. And I thought I'd just take a quick moment to show you actually what's inside the box when you receive your IQ. Okay, the first thing you may want to familiarize yourself with, we have a quick sheet here. On the quick sheet, we have what's in the case, which I'm about to take you through briefly. We have obviously the software. We have some pictures showing how different types of mounting techniques. Also, we have the cable connections, how to make all the proper types of connections. Okay. We have a little brief description of the IQ software that comes with the product, and also a field installation guide. Again, for your particular site, it's going to be it's possibly going to be different than what we're showing here, of course, but this is just to give you some idea. Okay. Also, if you're interested in real-time data, we do have a real-time display. I don't have that in the box with me today. But again, this quick sheet is just initially to use to familiarize yourself. We also have all our contact information right here in case you need to call us directly. Okay, we're always there to help. Okay, so here we have the IQ. It comes packed in here. Right here, this is not another smaller IQ or a keychain, but this is actually a USB drive. Okay, this is where we keep the software. And it has instructions for downloading the software on your computer. It comes with a toolbox. Okay, inside the toolbox, there's a little bit of hardware, a drill bit, some mounting brackets. I'll just take a minute to show you these real quick. The mounting brackets are actually designed, you can see there's little holes there. We can actually screw those in, and again, the hardware is there. And in this case, you would drill a hole into the channel bottom or into your mount, and you can mount it, and then you can align your IQ that way. Okay, so these brackets are here. We actually recommend that you mount the transducer or the housing as close as you can to the bed, of course, especially if you're in shallow conditions, and to try to minimize the amount of a mount or any type of anything you might have under it. Okay, again, that's in the really shallow water applications. Of course, every instrument like this comes with a variety of cables and connections. Your IQ should arrive with a power and communications cable. Again, this is the cable. I'll just show you quickly here. This plugs into the IQ. Okay. And this is on the side that goes into your shelter. Okay, here's the power connector right here. You plug that in right there. Depending upon how you connect power to it, I have a little power cable here. It actually operates between 7 and 14 volts, but I can plug it in there. Okay, and this also will provide, if I'm using an SDI 12 data logger, this provides the SDI line. Okay. Everything's pretty well marked. If you order the real-time display, basically everything on the real-time display here is in this little junction, this little module here, with the addition of the display and the 4 to 20 outputs. To actually talk to the device with our computer, your IQ should come with the RS2 to 232. A USB to 232 connector and an RS-232 cable. We always like to connect our computers using this RS-232 USB converter. Number one, it makes the communication much more reliable. COM ports on laptops tend to vary in quality, and so we've provided one of these actually just to minimize the complexities or the problems that may arise with the COM ports. Also, we have the cable plugs in here to give you a little more reach to the device. Here's our communication. This also can provide a Modbus communication as well. Okay, so here's all our connections sitting right here. Again, this is going to go to power. All right, simple little connection. This goes to the power supply. This actually is connected. It goes to the IQ. And this is where we provide communications. This is where we will connect to a computer to program it, to download data, or you may hook it into an existing network that you might have out in the field. Okay, that's about it. One last thing, in terms of for a power supply, if you have AC power, it also comes with an AC power supply here. Okay, so simple, a couple quick connections, and you're ready to go. Okay, what I want to show you here is just a quick example of how to program the instrument once it's been installed. Again, just briefly, I have the IQ software that I've installed and opened on my laptop. Here's the USB to 232 converter that's plugged into the RS-232 cable. Here's the power and communications interface. Okay, here's we're supplying the power. You can see the red light indicates that there's power to the system. And this is the terminal blocks with the cable actually that goes to the IQ that's installed in the water. Okay, what we have on the screen here is the SonTek-IQ software. This software comes with both the SonTek-IQ Standard and the IQ Plus. With this software, we're going to actually use it to deploy the instrument to collect data. And that is, we're going to program in the cross-sectional area. We're going to plan the sample time and duration. We can use the software also to download the instrument, and we can also use the software to review the data that we've collected. So the first thing I'm going to do is connect to the instrument. Once I've connected to the instrument, it's going to come up with this page. And what I can see here is I have system information, the standard settings, the channel shape, the flow settings, and my real-time data settings. Okay? In this case, I've already programmed the instrument. This is the instrument we actually used in the field today, and I've already programmed it to collect data. So I'm going to take you through that. As far as the system information, we're using the IQ Plus. It gives you the serial number, the firmware version. It's telling me that I have one new file on the recorder of the instrument that needs to be downloaded. It gives me the operating status. In this case, it's idle. We're not collecting any more data. And it gives me the available recorder space. The standard settings, this is where we set it up for our particular site. Okay, so I click on Change. And when I can enter the file name, the site name, the operator name, any comments. I'll input the salinity. In this case, in most cases, especially in irrigation, it's going to be set to 0. Okay, next we have the recorder. With the recorder, this is where we actually set up the instrument to collect data. We set first the sample duration, that is how long do we want to collect the data. And then in this case we have it set up for 180 seconds, which is 3 minutes. The next is we set as a sample interval. In this case, what the sample interval is how often we want to collect that data. In this case, it's also set to 180 seconds. When I have this type of setting, the instrument will actually literally run continuously. Okay? But what I'm going to do in a more practical case, we would typically set this instrument up to run possibly for 3 minutes, for example, every 15 minutes. In that case, I would set it to 180 for the duration and 900 seconds for the sample interval. The record profile data, if you're planning on doing a recalculation of the flow, or if you want to analyze the data further, you set this value to 1. In that case, we actually store all of the profile data, the data that we collected with that instrument, to calculate flow with every sample. For example, if I set this to 100, this would only be done every 100 samples. One of the advantages of setting it to 100 is that I significantly reduce the amount of recorder space. So if you're not planning on recalculating flow, or if you have everything set up to do flow automatically, typically you'll want to set this value to 100 or maybe even larger. Okay? If you set it to 0, actually no recalculation would be possible. In that case, you would significantly save on recorder space, the time for download, and all that. The align to sample hour. Okay, we have 3 choices. First of all, do not align. We can set the sample to start at the top of the hour or at the end of the hour. In this case, I'll set it to start at the top of the hour, and it gives me the days remaining. The battery power is next. This is basically gives you an estimate of our power consumption. Here we're using a 12-volt battery. We've got a 20 amp hour battery, and it basically is telling me I have about 46 days left of the recorder. Pardon me for that little screen there. Okay? So once I've entered all that information, it sends that to the IQ and it's programmed. Okay, the next thing that we do is we want to program in the channel shape. In this case, we've already programmed in the channel shape, okay, because this is the parabolic channel that we were using this morning. But I'll just click on Change to show you what we have inside here, what the options are. We can pick a couple different channel types. An irregular open channel, an open channel trapezoid, and a trapezoidal culvert, or also a stage area equation. We set the survey origin as the left bank or the right bank. Okay? This orientation is defined as you're looking downstream, and as you're looking downstream, to your left would be the left bank, to your right would be the right bank. Okay, the location of one thing, it's important for us to actually tell the instrument where it is within the cross section. Okay, and in this case, we installed the instrument and then we performed a channel survey where we measured the actual cross-sectional area of the channel, and we actually measured the instrument's location in that channel in terms of its position, its width across the channel, and its actually elevation in the channel. Okay, so we put the width here, which is y, which corresponds to this value here, y, and we put an instrument z, which is actually, again, there's an explanation there. The z is actually the height of the instrument relative to the channel cross section. Okay. The next thing is the actual survey data. We can program this in manually. We can also import channel data using a CSV file. We can append the survey point. We can insert survey point. There's literally an unlimited number of survey data points that you can use. Okay, so it's pretty simple, pretty quick. And we program the device. Now the next thing is I have to tell it, how am I going to calculate flow? I basically have two options. Okay, I have a theoretical calculation, or I have a velocity index calibration. The theoretical calibration, again, this discussion is rather lengthy, but this is the setting that I want to use if I want to have the IQ automatically calculate flow. If I want to provide my own equation to calculate flow, I can click index, and again, I can select my velocity type, okay, and put in my velocity index equation. In most cases, especially in the irrigation canals, you're going to simply select theoretical, and you'll be done. Now, to calculate total volume, I can to initialize the volume. Okay, if I want to initialize it or reset it, okay, I can set. If I want to start from the beginning, I'll want to initialize it or reset. But in this case, I'm going to leave it at continuous. Or I can, and if I give it initial volume, I can do it there. One thing, some of these irrigation canals, when they're not operating, that is, if the gate's closed or the pumps are off, we don't want the water's going to slosh around. We can set a lower a velocity threshold, a flow threshold, or a stage threshold that once it goes down to this minimum value, it will not compute a volume. Okay, that's just to avoid. That's a practical setting to avoid. Again, if the IQ is installed upstream of a gate and you have a gate shut and the flow may slosh back and forth, you do not want to be adding flow to that. So once that's done, the instrument goes and programs itself. And the last thing I need to tell is that how do I want to view the data? Okay, so in this case, I'm going to set it in meters, but I can set it in. I have many options. Okay, I can set the options on velocity. I can set the options on flow. Again, all of these come with different types of units. Okay, I can actually click on default, or I can set on default to metric or default to English, or I can mix them up if I'd like. The next thing is the output type. Okay, these are for units, and this is for the output type. I have a couple options here. Okay, I can when I output it to SonTek binary, that's telling it I'm just going to be storing data on the IQ. Periodically, I'll connect to a laptop and download the data that way. The next thing, if I want to use it for a polled mode or connected to a RS-232 device, I can set it for an ASCII output. I can also set it to a 4 to 20 milliamp output. SDI-12, which is a very common protocol used with a lot of modern data loggers, and of course Modbus. Okay, in this case I'm going to leave it set to binary because I'm just going to be talking to the instrument with my laptop. So once that instrument's been programmed, I can actually print the configuration and store it, or I can start collecting data. Okay, once I've set my real-time data, I'm just going to give you a quick review. Again, when we connect to the instrument, it's going to give us the system information. For the settings, we're going to tell it the file name and the site name, the operator, where we're at. Also, we're going to set the duration of the sample in the interval. The next thing that we have to change is actually the type of channel shape that we're going to use. There's a variety of different types of channel shapes, or I can input my own surveyed value. The next thing is I'm going to program the instrument about how to do the flow calculation. There's two basic calculations. One is a theoretical, which in most cases you'll be using. It doesn't require a calibration or a velocity index. The second, if you're in a natural, maybe possibly a large natural river or some very unique flow setting, you may want to develop your own discharge rating. In that case, there's a velocity index setting. The next thing I'm going to do is program the units that I want to use to collect data and also the output type. Once I've done all of this, I'm ready to start collecting data. I press the Start Data Collection, and now I'm collecting data. I'm just going to slide back up here to show you. Okay, now you can see the status has changed to collecting data. If I want to view live data, okay, I can click on View Live Data. And what you see here, again, everything is 0 right now because I haven't taken my first sample. But because it's going to be collecting data now for 3 minutes. When I get my first sample, this will update to say sample number 1. System in the water, of course, will be yes. It'll give me the calculated flow rate, the stage, the depth. This is just a quick review to make sure that this system is operating and collecting data. Okay, I'm just really looking at the sample data as it updates. Okay, one nice thing that we've done with this IQ is now, actually, while I'm collecting data, I can go out and download data. So I'll do that right now. Okay, so you can see I have 3 new files. So I'm going to go out and I'm going to click Download Data. Now, one thing, while I'm downloading this data, I'm still measuring. Okay, so I do not have to stop the instrument to download data. Okay, so I'll click Download All. It says all files successfully downloaded, and now I'm ready to go. So I'm still collecting data. Okay, in this case, I'm done programming it, and I simply hit Disconnect. Okay, and I'm done.